Continuing our discussion of probability distributions, now I want to look at expected values. So here are the extracts from the reference handbook, and the expected value of a discrete variable x with a probability mass function f of x is given by this expression. Mu is equal to the expected value of x is equal to the summation of k equals 1 to n xk times f of xk. So mu here we use for the expected value, not to be confused with mu that we previously used for the mean of a population. So basically what the expected value is the probability weighted average of all possible values. In other words, it's an average of all the values which are weighted by the individual probabilities of those individual values occurring. The variance is defined as here. Sigma squared is v of x, is the summation from k equals 1 to n of xk minus the expected value squared times f of xk. And what this is a measure of the dispersion or the range of the possible values around the expected value. Again, we also have the continuous variable to account for here, and the definition is given in the reference handbook, but I won't cover that here because I don't think questions about continuous variables are very likely. Let's do an example. Newborn babies are rated on the so-called APGAR scale, which ranges from 0 to 10. So 0 would be a baby in very poor health, up to the maximum of 10, which is a baby in very good health. And at a certain hospital, it's observed that the probability mass function of the scale is as shown here. Which of these is the expected value of the score for this hospital? So in this example, we have a score of x. X of 0 has a scale occurs 0.1% of the time. A score of 1 occurs 0.2% of the time, up to the maximum 10, which occurs approximately 1% of the time. So which of these is the expected value? Here is our definition of expected value, the summation k equals 1 to n xk f of xk. So in this case, we just form the products that this is equal to 0 times 0.001 plus 1 times 0.002, etc., up to 10 times 0.01, which is equal to 6.969. So the closest answer is C, which is 7. And this concludes my discussion of expected values.